Hello, I'll be walking you through how to execute the Driverless AI Python scoring pipeline with Apache MiNiFi C++. And we'll be using AWS to launch an EC2 instance. So let's click Launch, type Ubuntu, we're going to do 1804. The instance type is going to be T2 2x large. We'll keep the instance details default. Modify the storage to 256 gigabytes. Keep the add tags default. Security group will add a 9090 port, custom TCP, and zeros for source. Review and launch. Looks good. We'll click launch. We're going to choose an existing key pair. I had already created one ahead of time, so it's called EC2 model deployment, and then we'll click acknowledge. So we're going to copy the public DNS. I'll open the terminal. We're on Mac, so we're going to go to bash profile. That's where I have the environment variable that holds the public DNS, and it is called DAI scoring instance. We'll save. We'll close the terminal. Now our EC2 instance is running. We're going to reopen it. We'll do a history grep SSH. We're going to get one of these SSH commands. So what they do, we call SSH followed by -i. DAI scoring PEM is the environment variable that holds our PEM key, also known as our private key. And going back to the key pairs, when we set the key pair up, we also download a private key to our computer. That's the PEM key. This will allow for us to SSH into our EC2 instance without having to set a password, without having to enter a password. And then we have DAI scoring instance, and that holds our public DNS, and then the username. Ubuntu. Type yes. Okay, we're going to install Anaconda, so let's copy the link address. Git bash Anaconda, enter. This is the license agreement. If it's your first time installing Anaconda, I recommend you read it. Just scrolling through, acknowledging that we looked through it. We'll type yes, and then we'll click enter. Anaconda 3 will be installed in this location. Type yes. Okay, that was the the installer initializes the Anaconda 3. So now we'll exit, we're going to SSH back in, and Anaconda should be fully installed. Next, what we're going to do is we're going to create a virtual environment. Conda create, our virtual environment is called model deployment, and Python 3.6. Type Y for yes. We'll activate our virtual environment. Next, we're going to download MiNiFi C++. First, we're going to install some dependencies for it, like lib level db and libxml2. Alright, now we'll go to the link where I have the MiNiFi download, copy this link address there. Also, if you go to the MiNiFi download page, there will be a list of MiNiFi downloads that you can click on for particular operating system versions, and I chose the one for Ubuntu 18.04, and it brought us to that page. So now wget okay. You see here is we need to extract our MiNiFi tar.gz. Next, what we're going to do is we'll cd into MiNiFi. So now we're in this base directory of that. We're going to use this path to set the MiNiFi home environment variable. So on Linux, we go to the profile file, okay, and we're going to type in export MiNiFi home equals, and then that's our file. Exit, then SSH, and again. Now our environment variable has been set, and we're going to Anaconda activate model deployment. We want to make sure that we install all the necessary packages in the model deployment. So next, we need to install packages for the Driverless AI Python scoring pipeline. So I'm going to clone the DAI deployment and examples repository. So we'll say git clone on branch mojo py MiNiFi cpp, and then at this address. Alright, and I'm going to open another terminal window. And what we're going to do is, earlier I built an experiment using Driverless AI, and then I downloaded the Python scoring pipeline, and it's in my downloads folder. So I'm going to use the scp command. So what this has is it has the location of our score.zip, and it also has the location where we want to send it to on our EC2 instance. So we'll click enter. We'll let the transfer finish. Our score has transferred over successfully. Now what we're going to do is we're going to continue installing the dependencies. So we're going to run the update, making all the packages available on the EC2 instance. We're going to install OpenBLAS. That's for linear algebra calculations. Install unzip, because we'll need to unzip the score. We'll install OpenJDK 8. That's for the H203 algorithms. Next, we'll install GCC. Then we'll install G++. The CD to the Python to the hydraulic folder in DAI deployment examples, Mojo py MiNiFi CPP, onward to hydraulic. We're going to move our score.zip to this location. So we see it's there. Then we're going to unzip the score. We'll change to that directory, scoring pipeline. Then we're going to pip install git db2 and git db. Followed by, we're going to pip install the packages in the requirements text. And then the H2O AI core and H204 GPU, these errors we can ignore. The Python scoring pipeline should still work. Will still work. Alright, and what we're going to do next, before we can execute the Python scoring pipeline, we need to set Driverless AI license key as an environment variable. We're going to go back into the profile file, and we're going to set that environment variable. So we have export Driverless AI license key. We're going to copy and paste our license key after the equal sign. So I copy and pasted the Driverless AI license key, and then I saved and closed the profile file. So now what we'll do is we'll exit from our EC2 instance. Let's SSH back into it. And remember, we were in the model deployment virtual environment, so let's go back into it, because right now we're in base. Alright, and next what we'll do, so we need to add the Python processors to the MiNiFi folder from our DAI deployment examples, Mojo py MiNiFi CPP folder. So we'll go into the MiNiFi folder. Start out, we're going to create a modules directory, and this will hold an asset for 2 of our Python processors. Alright, and I have this module, it's called DAI Python score.py. It's in the DAI deployment examples folder under modules. So we'll expand that so you guys can see it. Path. We're going to copy that over to our current location. And there it is. So again, our 2 Python processors will be utilizing this module. And what that module is doing is it's importing the score from our scoring H2O AI experiment package. And what that looks like, I will show you guys so you can see it's right there. So what we're going to do next is we're going to go into the MiNiFi Python directory. We're going to create an H2O DAI PSP folder path, and then we're going to go into the H2O folder, and we're going to copy over our convert DS to CSV Python script. Again, this is also located in our DAI deployment examples under Mojo PY MiNiFi CPP, following those folder paths going to our Python script. We'll copy it over. Here it is. We'll do the same for our two other Python scripts that are related to the PSP Python scoring pipeline. So we have our execute DAI PSP batch scoring script we need to copy over, and we have our execute DAI PSP real-time scoring script we'll copy over. Right, and we're gonna go back to our config directory for the first time. We're going to this directory. What we're going to do here is we're going to overwrite our MiNiFi.properties file. So we'll just go again to the DAI deployment examples, and we're going to get MiNiFi properties and copy that over. And what we did to that file, if we go to the end here, there's a MiNiFi Python processor directory. When we overwrite the previous file, what we did was we added this path. So we just tell MiNiFi we have H2O Python processors in this directory H2O. Okay, so the way we build out data flows in MiNiFi is through writing config YAML files. And we could write one from scratch, but to save time, I'm going to show you guys how to import two different config YAML files. One that's for interactive scoring or real-time scoring, and the other that is for batch scoring. So we're going to copy the interactive scoring one over. And this is another asset from the DAI deployment examples, Mojo PY, MiNiFi CPP, onto that particular file. So we copy it over. We're going to overwrite the current config YAML. The config YAML that comes by default with MiNiFi CPP it is empty. It doesn't have any processors in it. So now let's see how it looks after we modify it. What we see here is the name of the MiNiFi flow, MiNiFi PY real-time scoring. We see our processors. Get file pulls data from test real-time data, execute DAI PSP real-time scoring. We tell MiNiFi where the script file is located. We also tell MiNiFi these are the predicted labels that I want you to add when you do real-time scoring. When you execute the Python scoring pipeline to do real-time scoring, I want you to add these labels. And then we have a convert DS to CSV. We tell MiNiFi where to find that script file, log attribute, update attribute, put file. We're saying we want you to write the prediction real-time data to this location, and then we have our connections. So how each processor connects to the next, eventually connecting to the put file processor. And now that we have that flow, what we can do is we can start MiNiFi. So let's go back one directory. Alright, and we'll SSH into the EC2 instance. And from this, again, I'm going to activate model deployment. Okay, and what you don't see right now is the logs directory that will be created once we start MiNiFi. Let's go in, tail file. So looks like everything's running successfully, which means all those processors that I showed you, data's flowing through them, and the real-time scoring is being computed, and it's flowing through to the put file, which then those scores get stored into a file that is saved onto the local file system on our EC2 instance. So let's turn off MiNiFi, and what we can do is we can check our location to where the predictions are written. So we'll check them here. Alright, just need to add that /. Okay, and we'll see that there are, yes, a few files that hold the predictions in them. Do a cat, and we can see cool, condition y3, 120, and then these are the decimals. We could also think of them as percentages. So 33% chance that it's a 3, 24% chance it's 100, and 20%. I meant 42% chance that it's 20. So 100 means cooling condition. The hydraulic cooling condition is fully functional. It's operating at its best efficiency, and 3 means it's about to fail, and 20 is reduced efficiency, reduced cooling. So we'll go back to logs, and what we're going to do now is we're going to run a batch scoring flow. Go back to MiNiFi, go into the directory, and this time we're going to copy over it's the config PSP batch scoring. So batch scoring, copy it over. We'll overwrite the current config file. Alright, we'll look in that config real quick. So we see it says batch scoring flow. The location where to get files pulling in data is from a different directory. Now it's test batch data. So difference here is we're pulling in a file or files that have multiple rows of data, whereas previously we were pulling in files that had only one row of data. And then we're writing out to a directory called prediction batch. So those are the main differences. Alright, with that set, all we need to do now is start MiNiFi, and we'll look at the logs as well. Okay, looks like the flow is working as expected. We're writing batch scores to a flow file, which then gets saved to the local file system using the put file processor. So let's go to the location where the batch scores are being stored. So we'll turn off MiNiFi. Oh, and what you see here, this is the flow file attributes. So this is from the log attribute processor, and we can see in this case cool condition 120 and 3, and you see there's that underscore 0. Since we're dealing with batch scores, we could end up printing out all of the batch scores in for the total batch scoring that we're doing, but I just printed out the first row of batch scores. Okay, and let's see where that is, the batch scores, the predictions. So we'll cd there. Here's the batch score. We're going to cat and then output it. So here are the batch scores, similar to real-time scores, but now we have batch predictions. So I hope this was helpful to you guys. We just went through how to execute the Driverless AI Python scoring pipeline with Apache MiNiFi C++ on an EC2 instance.